My name is Emily Volgamore, and I'm going to be explaining my Lyngbya final project. Lyngbya is a dense mat-forming cyanobacteria, an aggressive dominator with ideal biological morphological traits. Unfortunately, there is no method of control, and it's currently being studied in its very persistent habitat in Lake Gaston, which is in North Carolina and Virginia, split on the border. Because it is being studied in Lake Gaston, some of the data I used was from myself, but the other data I used was derived from government websites. My 3 analysis questions are: 1. What are the natural and ecological attributes that surround areas where Lyngbya has been identified in Lake Gaston? 2. With the addition of unnatural factors, what is the correlation to help identify future areas of concern? And 3. What is the total area of concern to be considered for next year's surveying and sampling? So again, my data was taken from NCDEQ as well as my own Gaston reports that span from 2016 and on. To go into my data, the Excel sheets were separate lab files that were taken, downloaded, and converted using an XY data method addition. And I was able to merge the data so it's collective, and then select only records containing Lyngbya within the North Carolina boundary that had multiple inputs. From there, I calculated the average results over the years, which was exported as a new shapefile that displays the average results of areas that have been sequentially sampled. In addition, I created a 10-meter buffer around the sites to account for the real-life 10-meter discrepancy we use in the field. For my geology layer, I clipped it to the Lake Gaston Lyngbya buffer area, and this was to display the various geological formation types, as sediment can often suspend or resuspend in the water column, and giving rise to nutrient additions. Composites with calcium carbonate or iron support persistent Lyngbya colonies, whereas my literary review has indicated copper as a suppressant. For my water quality analysis, I did not dissolve my layers, as my first question simply wanted to investigate natural parameters in Lake Gaston, but those were extended and clipped. And because Lyngbya is both transient, that's a reason I didn't kind of delve further in. I wanted to wait for Q2 and Q3 to deal with that, just because water is its own breed of cat. So here is kind of my baseline. I left the layer uncalculated because I zipped it and pushed it to my map. My questions that I wanted to answer were based on just the natural features. So looking at geology, I was able to deduce that we have 3 different types of sediment in Lake Gaston. I was also able to expand the Lyngbya to show Lyngbya instances and what are the surrounding plants in its small ecosystem. And then I was also able to expand the water quality so that I could see just exactly if it was impaired or not impaired and what were those parameters. And because impairment and water quality parameters are not often related, that's why I did not dissolve these. So, to go into my research that I pushed from a zip database into my map viewer, now here is my future data I'm going to be using. It's mostly land cover and unnatural factors, but to get into the map viewer, I was able to figure out that there are 3 geological types. There are a multitude of impairments and parameters, which I have denoted and displayed with various colors and symbology. And it's as expected, but we can see that there is fecal coliforms, high pH, low DO, toxicity, all very useful water quality and limnology indications, which will give rise to my Q2 and Q3 by relating these. And if you open up the Lyngbya, you can see that it goes into detail, and this is an average over the years.